Hi all. Today we'll be discussing the LeetCode problem of the day, meeting rooms 3. So you're given n rooms, index 0 to n minus 1, and you're also given 2D integer array meetings, which denotes start and end time of a meeting. And these meetings are half closed interval, and all the values of start are unique. So the meaning of half closed in the sense, if a meeting is from time duration, timestamp 6 to 9. So this meeting will finish before the 9. So 9 is not included. That means if another meeting is starting from 9 to maybe 12, so these both meetings will not clash because this is an open interval. So 9 is not included. That means this meeting is starting from timestamp 6 and it will end before the 9. And the new meeting, which can start at 9, will not clash with this. Okay. So now the meetings are allocated in these rooms in the following manner. So each meeting will take place in the unused room with the lowest number. So suppose at some point these two rooms are used and room number 1 and room number 3 are unused. And you have a meeting which you want to schedule. So out of these two unused rooms, you will pick the room with the lowest number and have this meeting in this room. Next, if there are no available rooms, the meeting will be delayed. So suppose you have a meeting which will start at 50 and it will run till 75. And all the rooms are used. Suppose in this room number 2, you have a meeting which is running from maybe 30 to 55. So you will wait till timestamp 55, and at 55, this meeting will get free. I mean, this room will get free. Then you can assign this meeting in this freed up room, and the duration will not get shortened. That means this meeting will start at 55 and it will end at 80. Because you should not reduce the duration of the meeting. Here the duration of the meeting is 75 minus 50, which is 25. Here also it is 80 minus 55, 25. Just the start time will change and the end time will also change based on the duration. And finally, when a particular room gets free, you have to the meeting which have the earliest original start time should be given the priority. So suppose again the same example. This meeting is from 30 to 55. And here you have two meetings waiting. One is 50 to 75 and another meeting, suppose, which is from 52 to 60. So once this room gets free, you have to give priority to this particular meeting because it has the lowest start time. Okay, and at the end of the all meetings, suppose this room held 2 meetings in total. This room held maybe 3 meetings, and this room held 1 meeting in total, and this room held 3 meetings. So you have to return the room which held the most meetings. And if there are multiple rooms with the same value, you have to return the room with the lowest number. So in this example, 3 is the maximum number of meetings that have occurred in any room. So out of these two rooms, you have to return the room with the lowest index. So in this case, your answer will be 1. Now let's quickly look at the examples. Yeah. In the first example, you have 2 rooms. So room number 0 and room number 1. Now the first meeting is from 0 to 10. So you will schedule a meeting from 0 to 10. Next meeting is from 1 to 5. So this room is occupied. So this is the only unoccupied room. So you will schedule this meeting in this room, 1 to 5. Next, you have a meeting from 2 to 7. So for this meeting, both the rooms are occupied. So you will wait until 5 seconds so that this meeting is free. This room is free. So at t equal to 5, you will schedule this meeting. And when you schedule this meeting, you see that the duration is from 2 to 7. That means the duration is 5 units. So when you schedule it, it will start at 5 and it will run till 10. So this meeting is also scheduled. After this, you have this meeting, which is from 3 to 4. So again, for 3 to 4, you see that both the rooms are occupied. So you wait till any of the room gets empty. So at t equal to 10, both the rooms get free up. Now, according to our uh, order, if you have multiple rooms empty, you have to pick the least room. So this meeting will be scheduled in this room number 0. So 3 to 4. So that's it. We have scheduled all of our meetings in the rooms. So if we count, in room 0, you have scheduled total 2 meetings. And in room 1 also, you have scheduled total of 2 meetings. So both are same. So you have to return the room with lowest index, which is 0. So the output will be 0. Now let's look at the second example. Here you have 3 meetings, 3 rooms, room number 0, room 1 and room 2. Okay. So first you have this meeting, which is from 1 to 20. So you will schedule it in this room number 0. Next 2 to 10, you will schedule it here. Next you have 3 to 5, you will schedule it here because this is the only free room available. 3 to 5. So this is done, this is done. Now you have a meeting which will start at 4 and end at 9. But if you look at this, all the rooms are empty. So you wait until one of the room gets empty. So at t equal to 5, this room gets empty. So this meeting is done, and at t equal to 5, this room is free. So you will schedule this meeting in room number 2. And you will start it at timestamp 5, and it will run till, here you have 9 minus 4 is 5. So it will run till 10. So the duration must remain same. So now this meeting is also scheduled. After this, you have final meeting, which is from 6 to 8. So for this, again, all the rooms are filled. So you will wait until any of the room gets empty. So at t equal to 10, both these meetings are completed. So both these rooms get free up. Now, since you have 2 rooms available and you always pick the least room which you want to schedule the meeting. So this meeting gets scheduled in the room number 1, which is 6 to 8. So now you have scheduled all of your meetings, and you will count in each room how many meetings you have scheduled. So in room number 0, you scheduled 1 meeting, and room number 1, you have 2 meetings scheduled, and room number 2, you have 2 meetings. So these 2 rooms have the maximum meeting schedule, and out of them, you have to return the room with the least index. So the output will be 1. Now coming to the constraints, the total number of rooms can be 100, and the number of meetings can be 10 power 5. Meetings of I.length is 2 because it contains start time and end time. And both start time and end time can be from 0 to 5 into 10 power 5. And it is guaranteed that all the start values are unique. Now let's go the approach, and we'll do it using this example where you have 3 rooms and you have some meetings which need to be scheduled. So first of all, if you want to schedule this meeting, you need to pick an unused room with the lowest number. So you have few meetings, right? You have few rooms, room number 0, room 1 and room 2. So whenever you have a meeting which you want to schedule, you somehow need to know what is the what are the all list of unused rooms available, and out of that unused rooms, you need to somehow pick the room with the lowest number. So to fulfill this criteria, we can use a priority queue, which will initially contain all the available rooms. So the priority queue will look something like this. It will contain an integer array, which is like, will contain first the finish time of the meeting, and then next it will have the room number. So in the priority queue, you will have integer array, and that integer array will contain the first index will contain the finish time of a particular meeting, and the next value will contain the room number. So let me just declare a priority queue for that. Okay, so initially we have 3 rooms. So all the 3 rooms are empty. So in the priority queue, let's put -1, 0, then -1, 1, -1, 2. So -1 indicates that this meeting will finish at time equal to -1. So it indicates that the room is basically free. And the next value will indicate the room number. So we can say this is a available priority queue, which will store all the available rooms. Next, if you see the point number 2, when you want to schedule a meeting and you don't have any rooms available. So in that case, your current meeting will be delayed until a room becomes free. So for this requirement, we also need to keep a track of all the meetings that are currently, all the rooms that are occupied, and which room will be free the earliest. So for that as well, we will use a priority queue. And suppose you want to schedule this meeting, and you see that all the rooms are occupied. So from this occupied priority queue, you will remove the first element. Since it's a priority queue, the first element will always contain a meeting which will finish first. So in that meeting, you will schedule your current meeting. So let's quickly do a dry run and see how this approach works. So yeah, initially you will have n equal to 3, which is the size of the number of rooms. So you will iterate and fill the available priority queue. So room number 0 is available, room 1 is available, and room 2 is also available. This is occupied priority queue. Now, first your meeting is 1, 20. So you look in your available priority queue and see that it is not empty. That means you have some rooms available. So from this available priority queue, you will remove the the top element. And this priority queue is first sorted based on the finish time. And if finish time is same, then it is sorted based on the room. So in this example, the finish times are all same. So the next check is based on the room number. So since 0 is the lowest room number, this gets removed. -1, 0. So that means in room number 0, you will schedule this meeting, which is starting from 1 and it ends till 20. So you can see that room number 0 is occupied and the meeting will run until time equal to 20. Since this room is occupied, we should put this in the occupied priority queue as well. So in the occupied priority queue, the meeting will end at 20 and that meeting is held in room number 0. So this is what you'll put in your occupied priority queue. And from your available, you will remove this. So this meeting is scheduled. Now coming to the next meeting, which is 3, 10. Again, you'll see that in the available, you have some rooms available. So you'll pop the top element, which comes out to be -1, 1. That means room number 1 is available. So you'll schedule this meeting in room number 1 and it runs till 10. So the same thing, you will put it in the priority queue as well. So it runs till 10 and the room number is 1. So this is also removed from your available priority queue. Okay. Next you have 4, 10. Again, you'll see that you have some rooms available. So you will pop this value, which is -1, 2. So this value indicates that room number 2 is empty you can go ahead and schedule this meeting in room number 2. This meeting will end at 10. So you will, in the priority queue, you will put 10, comma 2. So 10 indicates when the meeting is ending, and 2 indicates in which room that meeting is being held. Okay, so after scheduling 3 meetings, you can see that all the rooms are occupied. So currently, no rooms are available. Now let's see what happens when the next meeting arrives. So our next meeting is 11,15. Is 11,15. So here you'll see that your available is empty. So you'll check what is your start time. Your start time is 10. So before proceeding any further, you will see that in the occupied priority queue, you have some meetings which are ending before the current start time only. So this meeting is arriving at 11, but you can see that these 2 meetings are finishing before the 11 itself. That means before processing this meeting, these 2 rooms should be empty. So for that, what we can do is whenever we have a new meeting arriving, its start time is 11. So first we'll check in the occupied priority queue. We have to pop all the meetings which have a end time smaller than the current start time. So we see that this when we do occupied dot top, first you will remove this element, which is 10,1. So room number 1 gets freed. So you'll remove it from your occupied priority queue and you will add it in your available priority queue. And when you add it in your available priority queue, the end time you will put it as -1 and the room number is 1. Similarly, when you do occupied.top, you will have this value, this this meeting. And here also the end time is less than the current start time. So you will remove this as well. And you will add it in your available priority queue. So you will say the end time is -1 and the room number is 2. Here we are putting end time as -1 just to denote that the current room is empty. So this value can be any number which is less than 11. So we are just picking -1 for better clarity. So these 2 meetings are removed from our occupied. Also, if we look at the other meeting, which is this 20,0. So this meeting is not removed because the end time is 20 and your current meeting is starting at 11. So this meeting will go on before this meeting even starts. So this is not removed. Now you can see that in available, you have 2 rooms. So out of these 2 rooms, you will pick the room with the least room number. So you'll just do priority.top and top will return you this room. So priority.top will give you -1, 1. That means you can schedule this meeting in room number 1. So in room number 1, since this meeting was finished, in room number 1, you will schedule this meeting and this will run till time equal to 15. Yeah, and since we removed this meeting was also done. So once you are scheduling a meeting, this room number 1 is again occupied. So you will again insert it in your occupied priority queue. So this meeting will run till 15 and room number is 1. So this way we have successfully scheduled our 4th meeting, which is 11,15. Now let's move to the next meeting, which is 12,22. So for this 12,22, first we need to check if in the occupied any of the meetings are ending before 12. So we can see that both 20 and 15 are greater than 12, so nothing gets popped. Now we'll look in the available priority queue and remove the top value, which is -1, 2. So this indicates that room number 2 is free. So you will schedule this meeting in room number 2 and this will run till t equal to 22. And the same thing, you will put it in your occupied priority queue as well. So it will run till 22 and the room number is 2. So after this, your available, no rooms are available and all the 3 rooms are occupied. Now we are at this meeting, which is starting from 14 and it will run till 25. Okay. So for this, we'll first look in the occupied again and see if any of the values are smaller than 14 so that they will finish before this meeting is starting. So we can see all the values are greater than 14. So 14. So none of the meetings get popped. But now we can see that available is empty. So no rooms are available. So you don't know in which room you have to schedule this meeting. So to know that, in the occupied priority queue, you need to wait until any of the room gets free. So if we see here, we can see that at t equal to 15, this room will become empty. So the same thing we can get it from a priority queue. If you do priority.top, it will return you this value, this entry, because since the priority queue is sorted based on the finish time first and then the room number, and this value has the least finish time. So this 15,1 gets popped. So you'll remove this 15,1 from your occupied priority queue and you'll insert it in your available. So this indicates that for this meeting, you will wait for some time. And this room number 1 is the first room that will be freed up. So from your available, when you pop the value, you will get the value as 15,1. So when you pop the value, you can see that the room number is 1. But in the room number 1, the meeting is currently going on. So at t equal to 14, you can't schedule the meeting yet. So you have to wait till time 15 and then only you can schedule this meeting. So you'll schedule this meeting at t equal to 15 and this meeting will run till 26. So it will run till 26. So it's running till 26 because you're starting one second late. So because of that, the meeting will end 1 second late. So the same entry, you'll again add it in your occupied priority queue. So the meeting will run till 26 and the room number is 1. And this gets removed from your available. Okay, and finally you have the last meeting, which is 21,30. So before processing this 21,30, again, first you'll check in your occupied priority queue whether any of the meetings are ending before 21. And you can see that 20 is less than 21. So this gets popped. And the same thing gets added in your available. So ending is -1 and the room number is 0. Yeah. So now when you want to schedule this meeting, which is starting at 21,30, you see that room number 0 is available. So you can easily schedule this in your room number 0. So in room number 0, you'll schedule this meeting. So it will run till time equal to 30. And in your occupied priority queue, you will put 30 and the room number is 0. And you will remove it from your available priority queue. So after this, we have scheduled all the meetings. If we look in this room number 0, we have held 2 meetings. In room number 1, we have held 3 meetings. And in room number 2, we have held total 2 meetings. So out of this, 3 is the maximum. So you'll return room number 1 as your answer. And to store this, you can just keep a count array. And whenever you are scheduling a meeting in any particular room, just increase the count. And at the end, just count which room has the maximum frequency. Now let's quickly code the approach. So first, let me take 2 priority queues. It will contain integer array versus available. So, priority queue. And similarly, we'll take another priority queue, which will contain all the occupied rooms. Also, this priority queue should have a custom comparator. First, we want to compare it based on the end time. And if end time is same, then we want to compare it based on the room. So for that, we can create a comparator class. So compare. So in the priority queue, whenever we add, you have two integer arrays, and the way we compare is if a of 0 is not equal to b of 0, that means if the end time is matching, then we want to compare it based on the room number. So we just return teacher dot a of 1 comma b of 1, and if the start time is differing, then we can simply compare it based on the start time itself. So we just return integer dot compare a of 0 and b of 0. Right. Also, one thing I forgot to mention, in the priority queue, we are storing the end time and the room number. So if we quickly look at the constraints, the start time and end time can go until 5 into 10 power 5. So what if you have 10 power 5 meetings and all the meetings have a start time at 0 and end time 5 into 10 power 5, and you have only a single room. Let's just take 10 power 5 for simplicity. So all the meetings start at 0 and end at 10 power 5 and only one room. So the first meeting will run from 0 to 10 power 5. Then the second meeting, it has to wait until the first meeting is completed. So first meeting will get done at 10 power 5. So the second meeting will start at 10 power 5 and it will run till 2 into 10 power 5. Next, the third meeting will start at 2 into 10 power 5 and it will run till 3 into 10 power 5. So similarly, if we have a total 10 power 5 meetings, the last meeting will start at maybe 10 power 5 into 10 power 5 and it will run till just 10 power 5 into 10 power 5 plus 1, which is 10 power 10 plus 10 power 5. So by this, what I mean to say is the end time will definitely exceed the integer range. So in the priority queue, instead of int, we have to take a long. So let me quickly change this int to long to prevent the overflow. Long, and here also we need to do long.compare. Yeah, so here the priority queues are done. So the first thing we need to do is all the rooms are available. So we'll iterate on all the rooms, I less than n, and we'll just put it in the available priority queue. Available.add new, long, and the end time is -1 and the room number is I. And since it's a long, we need to insert -1L. So also in the question, it is nowhere mentioned that you are given the meeting based on the start time. I mean, sorted based on the start time. So first you need to sort the meetings based on the start time. So for that, we can use arrays.sort meetings. And to compare, we'll have a comma b, a of 0 comma b of 0. So the meetings will be compared, the meetings will be sorted based on the a of 0, which is the start time. And the start time is always, I think it's always unique. So yeah, once the meetings are sorted and once you have all the available priority queue filled up, you can start iterating on the meetings and schedule them one by one. So let's iterate on the meetings. Meeting in meetings. Also, we need to declare few variables. First, which will store the count, which means in it will store the count of meetings held in each room. And we also need answer. So index, initially let's take it some big value since we are trying to minimize this index value. And also let's have a min value, which is the number of meetings, the max number of, sorry, let's take max, which denotes the max number of meetings occurred in any of the room. So first, whenever we have a meeting, we need to look in our occupied priority queue and remove all the meetings which are already completed. So for that, we can say file so as long as occupied is not empty, and occupied dot peak, I mean the top value of the occupied priority queue, which it will give us an integer array which will store the start time and the room number. So if we do 0, it will give us the start time. So if this value is smaller than equal to your current meeting start time, sorry, this one is the end time of the meeting which is currently going on. So if the end time of this meeting is less than equal to meeting of 0, that means the end time is less than equal to the current meeting's start time. That means this room is freed up. So we can just say available dot add so long, and you have the values as -1, and the room number will be occupied dot peak of 1. So this will give you the room number. And once you do this, you have to remove this value from your occupied because you're adding it in your available. So for removing, we can just use a poll here. So if you use poll, then it will remove the value and you'll just get the room number from this. Okay, so once that is done, we will need to check if your available priority queue is empty. Available dot is empty. Okay, so if the available priority queue is empty, that means currently we don't have any rooms available, so you can't schedule this meeting. So for that, you need to wait until one of the room from your occupied priority queue is free. So for that, you can just add available.add. From your occupied, you will remove the top value and add it in your available priority queue. So top.poll. Okay, so now when you do available.poll, this will give you the information about the current room and when the room is getting freed up. So maybe we can store it somewhere equal to available.poll. So the first thing you'll check is your current meeting start time, which is meeting of 0. It is greater than equal to your room of 0. So that means your current meeting can start at the original start time only. You don't have to delay this meeting. So for that, you can just add it in your occupied priority queue. Occupied.add. This current meeting will run till meetings of I. So it will run till meetings of 1. And the room number, you can get it from this value. Room of 1. Occupied.add new song. So yeah, this is the case when you don't need to delay this meeting. Else case means the current meeting has to be delayed until this room gets freed up. So same thing, you will add it, but the end time will differ. So the end time will differ by the current start time, which is sorry, the current end time, which is room of 0 minus the start time of the meeting plus meetings of 5. So let's just look at this through an example, and it'll be a bit clear. So let's say my room is something like this. It will be freed up at 50. The room number is 2. Now you have a current meeting. Your meeting wants to start at 45 and it will run till 80. So in this case, you'll see if your meetings of 0, which is 45, whether if it's greater than or equal to room of 0. So it's not greater than room of 0. So it goes to the else case. In the else case, this meeting is delayed by 5 units. And the 5 units, you can get it by doing 50 minus 45. So this is what we did. 50 minus 45, which will give you the 5 units you have to wait. And that 5 units, you will add it to your end time. So your previous end time was 80. Now your new end time will be 80 plus 5, which is 85. So that's what you will add it in your occupied priority queue. So once all this is done, you will need to count this room frequency. So that means count of room of 1 plus plus. We are just counting that in this room, one more meeting is held. So once this is done, let's quickly check the frequency. Let's have frequency equal to count of room. Also here room is long, so we need to typecast it to int. Yeah, once you have the frequency, if your frequency is greater than max, then you will say max equal to frequency, and index will be room of 1 int. Also, you have a case where if the frequencies are equal, you need to return the index with the lowest value. So for that, let's just handle that case as well. So else if frequency is exactly equal to max and your current room number, which is room of 1, is less than your index value. In that case, you can just update your index equal to room of 1. And here also, I think we need to typecast to int because room of 1 is a long variable. And yeah, that's it. So when all the meetings are done, we just return the index. Okay, we have few errors. Okay, in this comparator, we are passing a long array. What next? In this will.add new long. Okay, so while initializing the priority queue, I have declared the comparator class, but I have not used it. So here we need to pass the comparator class. So comparator. And the same thing for the occupied priority queue as well. So here while comparing, there's a small mistake here. So if a of 0 and b of 0 are not equal, that means the start time is not equal, then we have to compare it based on the start time. Sorry, the end time. And if the end times are equal, then we have to compare it based on the room number. Now let me test it. Okay, let me submit. Yeah, and it works. Finally, let's do time and space complexity analysis. So n will be the number of rooms, and for the meeting's length, let's assume it as m. So here when we sort the meetings array, the complexity will be m log m. And here we're iterating on the n, so order of n. Here we're iterating on the meetings again, which is order of m. And inside that, we are doing some operations on the priority queue. and the removing or inserting in the priority queue has a complexity of logN. So this for loop will have a complexity of m log n. So total complexity will be m log m plus m log n. So we can just take this m as common. Yeah, so total time complexity will be m into log m plus log n. Now coming to the space complexity, we are creating two priority queues, and the maximum size of the priority queues can be up to n, and we have also created a count array, which is again order of n. So the total space complexity will be order of n. I also have the code in Python if anyone wants to view it. I'll add this in the description as well, and let's catch up in the next video.